The story of Ethernet is best told in personal stories shared by its very own creators, providers, and users. The Voices of Ethernet archive is dedicated to preserving Ethernet's oral history, recording pivotal events that may have been forgotten or remain unknown, through a collection of spoken records with the individuals engaged in the technology's global emergence as the foundation of Internet.
So today for Voices of Ethernet, we're talking to Tony Jeffree. Tony, thanks for joining us. If you happened to be there at the time, we had the argument about whether we should go to EUI 64-bit addresses instead of 48.
Yes, there were various ongoing discussions about 64 versus 48 and how to integrate them and so on and so forth. And of course, the reality with number spaces is that you can't put a quart into a pint pot. I mean, like, surprise, surprise, if you have 48 bits, you can put those in 64 bits. That's easy enough. If you have 64 bits, you can't represent them in 48 bits. Well, okay, so you have to choose one. And there were all sorts of discussions around whether it was possible to put together a scheme where you could integrate the two, but actually, the short answer was choose one, stick to it, and get over it, really. So in the few cases where 802 standards ended up with 64-bit address spaces, they pretty much had to reduce their effective number space to 48 in order to talk to the rest of the world, or use a router. I mean, it's not a big surprise, really.
So related to this topic, there was the time where we shifted from 802.3 to Ethernet. I'm guessing this was sort of somewhere in that period as well, because there used to be standards such as LLC 802.2, and there used to be a link field which became a type field.
Ethernet as in Ethertype, yes, indeed. That pretty much coincided with 802.5 disappearing from view, because they were pretty much the only people that cared about LLC. Surprise, surprise, because they didn't have an Ethertype in their frame format. And .3 and .1 didn't really much care about LLC. It didn't have any great value for us. In fact, it was a pain in the backside, frankly. Yeah, I mean, pretty much at the point where 802.5 became, a non-protocol. Ethernet and using Ethertypes for Ethernet networks was the obvious way to go, really.
So if you took a look back, right, I mean, the standards development world is a very strange world, and you did mention something about the set of people who show up is strange.
Yeah.
If you sort of, if you were trying to explain it to the outside world as to how it is you succeed in that world, right, or how do you think about how success happens?
I think the primary way success happens is by not being too not being too optimistic about how far you can go. If you follow me, that's not expressed very well. I guess the expression "don't try to boil the ocean" springs to mind. Okay, there's an inevitable tendency in all projects that you get project creep and scope creep setting in. People say, oh well, let's just add this other new feature, and I've got this other thing that I want to do, we can just sneak it in here, and suddenly you've got this gargantuan mess, and nobody really knows what they're trying to implement anymore. So what we tried to do in .1 at least was to make sure that we had a very clear idea of what the scope of our project was, and we would test what we were doing against that scope on a fairly regular basis. And if there was any scope creep, we would actually do the decent thing and go back and change the par and say, well, actually, we want to include this in it, because strictly speaking, if you produced a standard that was that exceeded your par, you could be pulled up on it and told you were a naughty boy. So that's certainly one aspect of what we felt went for a successful standards process. That stay within your scope, be realistic about what the scope is, and importantly, limit it to stuff where there's an existence proof of a solution. Standards work very well when you take an existing technology and you develop a common view of what that technology is and what its rules are. Standards development works very badly when you treat it as a research and development project. I mean, that way basically lies disaster. And
yes, here be dragons.
Yes, here be dragons, very large, very nasty dragons, and things go on for years and years, and you get nowhere. So
I am reminded that in .3 we vote quite a lot, and in .1 you run a more consensus model where you basically never vote unless you know you're going to win.
That's absolutely right, and we nurtured that way of looking at the process. It was something that Bill Ladinsky set up when he was chair, and we saw that it worked well, and we carried it on. That essentially, the way we worked was to build consensus in the technical meetings, and once we'd understood what the technical consensus was, we could take a vote in the closing plenary and say, we have agreed that this is the consensus, and those votes almost invariably passed. It was very rare that we had a punch up in that final discussion. And on the very few occasions when we didn't go down that route, when I mean, there was one occasion when there was a binding vote taken in one of the task group technical meetings, and it went, well, it went whatever way it went, and at which point the meeting broke for coffee, and there was a lot of discussion over coffee as to how that vote had gone and whether it was the right thing to do, and so on and so forth. And after the coffee break, the meeting reconvened and decided that vote was a really bad idea, and they rescinded it.
So along this path, even though .1 started off really looking at a lot of different physical media, to a large extent it's become joined at the hip with Ethernet. I just wonder,
very much,
if you could express some opinions as to how they contributed to each other's success.
It's kind of an obvious synergy, really, that bridges need something to connect them together, and Ethernet segments need bridges to connect them together. I mean, that's the sort of trivial answer to that question. We were developing different parts of the same of the overall network. The Ethernet frame ended up being extended in various ways by the work that we did. We added a VLAN tag to it, we added another VLAN tag to that, and we did Mac and Mac, and we did other crazy things. And so for a while we were going through this meeting's Ethernet frame size discussion. And eventually we reached the point where it said, okay, well, this has got to happen once and for all. We're going to make a final decision. This is going to be the maximum frame size that an Ethernet frame will ever have, regardless of what .1 decides to add in terms of bridging functionality.
The envelope frame.
The envelope frame, the overall frame. The actual data portion of the frame stayed the same through all of these discussions. We were adding bits on the front.
So at this stage, it would be reasonable to say that that's what the standard said, and many things happened outside the standard.
Yeah. I mean, there are other things happen, obviously. But the
way I tend to think about this was, I think it was the right mix between .3 did just enough and .1 did just enough, whereas maybe the other Macs tried to do too much. And so I think it became everyone did what they needed to do, but nothing else.
Yes, yes, indeed, and that I think is another great principle. You know, when you're looking at standards and what makes a good standard. I mean, I remember a fascinating discussion that I had. I did a bit of consultancy with the guys at CERN, and at the time they were looking at Ethernet and rapid spanning tree and the 802.1 AS time sync as the basis for essentially wiring up the LHR for Ethernet, and their spec for this was they needed the time sync to be at least as good as 2 nanoseconds. Okay, so the synchronization node to node had to be no worse than 2 nanoseconds. The demonstration involved a kilometer of fiber optic cable and 2 nodes, and you heated up this kilometer of cable with a hairdryer, which made it longer, of course, and therefore skewed the time sync between the 2 nodes. And you could see on the scope, you know, the two nodes getting back into sync, and it always stayed within 2 nanoseconds. So at a meeting fairly soon after that, we got this guy to come and give a talk to .1 about what he'd been doing and how he'd been doing it, which was utterly fascinating because at the time, most of the people implementing rapid spanning tree were looking at, you know, a couple of orders of magnitude worse than you know, the sort of speed of reconfiguration that these guys needed, and a couple of orders of magnitude worse in terms of the time synchronization between nodes. And so it was fascinating for them to see what was possible. And one guy stuck his hand up, you know, in the question session and said, you know, you got to 2 nanosecond synchronization. Did you think about going any further? And he said, nope. And question, why not? It was good enough. And that absolutely, you know, was a fascinating, you know, these guys were engineers. They had a problem to solve. They weren't into the business of researching Ethernet networks. They were into the business of researching particle physics, and you know, Ethernet was a tool to get them there. And they had a spec, and they once they meet that spec, they're done. And
I'm reminded of advice I got from someone, it may have been you or someone else. A standard is not done until there's nothing left to take out.
Yes, that's another way of looking at the same thing. That you start the development process by putting loads of stuff in the document, and then, you know, when you pare it down to the absolute minimum that you need to keep in the document, then you're done.
So I'm going to move along because otherwise we could make this 10 hours. So you want to reflect on from where you started, which is old serial world, where we are today, right? There's been huge changes.
There have been, yes. I mean, the most obvious change is that pretty much everywhere you look, you've got Ethernet, you've got Wi-Fi, or a combination of both. Wi-Fi, of course, is these days the thing that is much more visible than Ethernet, because Ethernet is just the plumbing, it's the wiring down below. But of course, as we well know, without Ethernet, the Wi-Fi would be kind of lost, you know. And that doesn't even get fixed by mesh, but that's a whole other discussion. we probably better not go there.
I guess I'm reminded that, as you mentioned earlier, having being definitely well retired, and you've bought a pub, and now your question is you have to put the network in the pub. And if you think about where we were to now, it's like, yeah, it's just connectivity is everywhere.
Yes, absolutely. And what people don't realize about Ethernet.
So just for fun, so just remind us where you are at the minute, Tony.
I'm on the Isle of Mull, which is in the Inner Hebrides, just off the west coast of Scotland.
A long way away, and somewhere, you know, not somewhere you would think, oh, I'll have communications. I can video conference with these people.
Well, absolutely. But of course, we're currently video conferencing using the services of Elon Musk with his Starlink, because essentially that's the only game in town at the moment. But there you go. But
I guess these packets are going across an awful lot of Ethernet links.
They're going across a very large number of Ethernet links, and actually a fair number of Ethernet links just in my house. But there you go. But what people fail to realize about Ethernet is just how pervasive it is becoming. It's not just about conventional data processing type activities and video conferencing and so on. It is invading our cars. It's invading the technology that we use for invading. Yes, it is replacing bits of the wiring loop in your car in order to reduce the amount of copper that's used, and add functionality and so on and so forth. It's doing the same thing in planes. It's very much doing the same thing in process control, which is where I started in this gig back in 1975. And for me, that's a fascinating sort of full circle thing.
I was going to ask you later about what you're keeping track of, and it seems that you're actually keeping track of some of the stuff I'm really interested in, which is the movement of Ethernet into the OT world.
Yes, indeed.
You've been tracking the fact we're doing 10 megabit again.
Well, yeah, and why not?
And multi-drop.
Yeah, but that's fascinating in itself, because of course back in the days when the .5, .3 wars were still, and .4 wars, come to that, were still in full flood. People were saying that Ethernet could never do real-time activities, and that's patently not the case. We had in the time that I was still at .1, a very active series of projects working on support for audio, video, and manufacturing, and so on and so forth. And it's a whole area that I'm sure will become very interesting in the coming years.
All right. So, in the interest of self-promotion, what do you think about putting this sort of history together?
I think it's a great idea. It's, clearly the case. You just have to look at the hair color to realize that some of us guys that were there in the early days of 802 won't necessarily be around for many years to come. And in fact, some of the people that were involved in the early days have already departed, unfortunately. So getting these sorts of stories down, and getting a bit of background into the real life aspects of how these standards came into being, I think is a great idea.
All right. So any final thoughts?
Yeah, I mean it's. I think we've mostly covered what I had in the way of final thoughts, which was really around that it's been a fascinating area to work in. If I had any advice for somebody who's contemplating going into standards development, on the one hand, the advice might be run a mile, because you'll get sucked in and you'll stay in that activity for 30 years like I did. But on the other hand, it's been a massively rewarding exercise too. Pretty rewarding way to spend 30 years of your career. And it's a great way to meet some pretty smart engineers and go to restaurants and things.
So Tony,
yes,
thank you so much for your time today. I really appreciate it. I do miss seeing you at the meetings, but maybe I'll get to Scotland sometime.
That would be good. Yeah, you'd be very welcome.
Thank you so much. All right, so this is the end of our story from Tony Jeffree. So tune in to hear other Voice of Ethernet stories, and I look forward to seeing you on another videocast.
Tune in to hear other voices of Ethernet as we continue to document the evolution of Ethernet since 1973 and explore where the technology's story might go next. Thanks for joining.